as we start the scientific method, we always start with an observation. And after we observe, what do we do?
Hypothesize.
I actually want you to ask a question. The reason for that being a hypothesis is a potential answer to a question, right? So if you're going to answer a question, you must have asked a question. Does it have to be a brilliant question? Is sometimes it not a brilliant question? How do we make it a better question?
Research it.
You research it. So we make an observation, we ask a question, we do some research, and then based on research, we can then ask a better question. Now on that note, you guys are kind of hamstrung with your experimental designs that you did while everyone else was on retreat, because I gave you a question that's not technically really that awesome of a question. But you were free to do as much research as you needed to do. You all came equipped with iPads, right? So you had the necessary tools to do some more research. After you ask a question, then what do? You can hypothesize. And a hypothesis is not what? Altogether. Right, it's not an educated guess. What is it? We know what it is not, so let's determine what it is. Chad.
A prediction of results based on prior knowledge.
So it's a prediction of results based on prior knowledge, which is fascinating. I had a doctor's appointment last night, and of course my doctor I think she's actually more anxious to find out whether this is a boy or a girl than I am. She doesn't particularly care for when her patients choose to not find out, mostly because she really wants to know. She likes knowing, and she's like, well, I mean, there's no real good way to tell whether it's a boy or a girl other than the ultrasound or genetic testing. Some people say that heart rate is a good way to tell the baby's heart rate. If it's above a certain number, it's supposed to be a girl. If it's below a certain number, it's supposed to be a boy. And then she said, it made me laugh pretty hard. She's like, but even that's 50-50. And I was like, isn't it already 50-50? Like, you have not, increased the odds of accuracy at all, have you? And she goes, well, I'm looking for something that's better than a coin toss. And I was like, isn't that also 50-50? Like, everything you have listed so far, the odds here, we're looking 50-50. So guess what, kids? The odds are still 50-50. I know you're shocked. You're like, wow, I really anticipated you're going to come in with some great piece of knowledge. Nope, that's what I learned at the doctor yesterday. 50-50. I like her a whole awful lot. So my prediction based on prior knowledge, my prior knowledge tells me that the odds are 50-50 it'll be a boy or a girl. 50-50, it's going to be a boy or a girl. There's my prediction. Woohoo! I know, you're all like, that doesn't tell me anything. Correct. That tells you nothing. But it's the best that we can do based on prior knowledge, because we don't guess. Some of you are like, no, I've guessed. I know what it is. All right. Gets closer to due date. I'll have you rapscallions make your best guess. Weight, gender. I'll let you do it. Ooh, we can do it for a prize. What kind of prize? Candy. Candy seems like a good prize. I like candy. After you hypothesize, you make your not guess. You have to test your not guess, right? Testing your not guess is called an experiment. Now I have to tell you something special about your not guess. If you phrase your not guess in a very specific way, you can design your experiment without having to put a whole lot of thought into it. If you write your hypothesis as an if ... then ... statement, you have automatically designed your experiment. I will give you some examples off the top of my head of truly horrendous experiments that are boring and lame, but it lets us talk about a hypothesis. If I apply 3 times more nitrogen to the soil, the beans will grow 3 times as many beans. Is that a hypothesis? If I apply 3 times as much nitrogen to the soil, then the beans will grow 3 times as many beans. Is that a good hypothesis? Why not?
Because you need other things to grow beans than nitrogen.
Well, what am I testing in that scenario?
Whether or not nitrogen makes the beans grow.
Whether or not nitrogen makes the beans grow what? Think about how I phrased my hypothesis. If I apply 3 times more nitrogen, then it will grow 3 times more beans. The amount of beans. Do I have 2 things there that I can measure? Can I measure the amount of nitrogen I apply?
Yes.
That's a measurable quantity. Can I measure in some way the number of beans? Is counting a measurement?
Yes.
Okay. So that, while it is a kind of lame experiment, is actually a well-crafted hypothesis because it makes both variables measurable. If I were to say, if I apply nitrogen fertilizer, then the beans will grow more. More what? More leaves, more roots. They'll grow taller. They'll grow more beans. I can't measure that, can I? It's not very specific. So when you craft your hypothesis, make sure a hypothesis is crafted in a way that both parts, the if and the then of the statement, are measurable. Specific and measurable. That's what we always, always, always aim for. Specific and measurable. Because I am a lazy, lazy scientist, measurable preferably occurs in the metric system. I prefer the metric system because, friends, it's divisible by 10. I am confident I'm capable of sliding a decimal point over. I'm good with that. This whole nonsense of a system where I divide by 12 or 36 or 5,000 whatever, like who does that? Like it's 5,000 whatever because, I mean, truthfully, really, like who does that? Like, I don't know, whatever. 3 feet in a yard. Okay. This doesn't bother the rest of you? All right, so I'm not going to lie to you. Here's my most practical application of why the system that we use is dumb. So next week, Coach P and I covered it. I'm afraid of this thing. Coach P and I will be running for Homecoming King and Queen. And part of the way that we are going to run for Homecoming King and Queen is I'm going to have a bake sale. I told some of you guys about it on retreat. So I have been preparing baked goods, preparing doughs and freezing raw doughs in portions so I can bake them next week so they will be fresh baked goods. But I've been doubling and tripling recipes because a dozen cookies will not feed many of you, but like 5 dozen will. So I've had to double and triple recipes. Seriously, when you double a tablespoon, okay, you're like, fine, 2 tablespoons. But when you like quintuple that, you end up with how much?
4 tablespoons. 5 tablespoons.
5 tablespoons. 5 tablespoons, like 5 tablespoons is more than a quarter of a cup, right? How many tablespoons are in a quarter of a cup? See? Nobody knows. So you have to Google it. And then your iPad gets like ingredients all over it because you're Googling things.
On the board it says hashtag Bluefield 2015 and when two began breeding. What does that mean?
Coach P and I were homecoming king and queen last year, but there were just 2 of us. And now there are 3 of us. So this is the year there became 3 of us. Slightly sad though, because part of my motivation for winning last year was because if I won, I was going to chest bump Coach P, because that's one of those football things that I'm like, I don't understand it. Like, why do people run at each other and then jump so they can bounce off each other? That seems like a terrible idea. Like, there's never been a moment in my life that I've been like, I should go bounce off that human. And, right? So I was teasing Coach P. I was like, yeah, you know, if we win, I got to chest bump you. So we practiced the chest bump all week. So as to not get hurt. I don't know if you noticed, there's something slightly different in the way that Coach P and I are shaped and built, that there was high probability of injury on my part if this were executed improperly. So this year we're a little sad because there will be no chest bump. My doctor has strictly forbidden it. She's like, no, you can't. I asked yesterday. I was like, are you sure? And she's like, I'm still sure. That's a bad idea. So, little person prevents us from the chest bump. Sorry, little person. But seriously, metric system, because for real, I don't know. I can't tell you how many ounces are in a gallon.
16. No, 48. 64.
See, it's a debate. You're like 16, 32, 64, 905. I don't know. So metric system. Metric system. But you knew that already, right? Because it's science. Nick, by the way, before I forget to give you this, I'm just going to continue to hold this piece of paper as it was handed to me. We both knew it was for you, and I just kept holding.
Because I saw Lorenzo coming.
Right? I think from now on, can we just send Lorenzo to you?
Okay.
Excellent. That way I don't have to deal with the piece of paper. Specific, measurable. Is counting a measurement in the metric system? Like 1, 2, 3, 4, 5? Yes. Hand count is in fact. For specific, measurable, and I do believe if you write an if-then statement, it's going to tell us what data we collect. An if-then statement is crafted such that it tells us exactly what our experiment is going to be testing. The if, God bless you, the if is the independent variable. That is what the researcher themselves manipulate. Where the then is the dependent variable. That's what the researcher is going to record. So the if is the independent variable, the then is the dependent variable. Every good experiment tests only one variable at a time. That's what we aim for. If written in this way, it's going to tell us precisely about the data we collect. Now, if you design an experiment, you should make sure that you have in your experiment, a procedure, a process, how to do this, all that. And you should tell the individual, or whoever's looking at your experiment, this is the information we want to get out of it. There's a thing about data I'm going to warn you about. There are 2 kinds of data. If I ask you for something measurable, I always want quantitative data. So if-then statements tell us what kind of data we're going to collect. Every experiment must have data. And the 2 types are quantitative and qualitative. The best experiments, the dependent variable will be quantitative. It will be something that can be measured numerically with a ruler or a graduated cylinder or a balance. It's something we have a measuring device that we can measure.
So like counting the number of tomatoes that grow.
That's going to be quantitative. Or for our bean experiment, how about saying instead of number of beans, we could do mass of beans. And I could just pick the beans off the plant and put them on a balance and mass them, right? That's quantitative data. Here are things that scientists hate. Qualitative data. If I apply nitrogen fertilizer, then the leaves will be more green. Listen, anything that involves color is automatically going to be subjective. How do I know? Because my husband can't match things to save his soul. Like, he'll come to me and be like, what can I wear with these blue pants? And I'm like, well, you should probably start with the fact those pants are not blue. Right? We all know that person. We can never agree on something subjective like color because there's no way to measure that. So we don't ever want qualitative data like color. That's just dreadful. Dreadful, dreadful, dreadful.